Welcome to Jackson Squared. Today we're going to be looking at how to convert an improper fraction to a mixed number and a mixed number back into an improper fraction. We're going to be doing this using models called tape diagrams or strip diagrams or just any other model that we may have seen in the past. So let's get started and jump right in with vocabulary. A fraction represents, what is a fraction? A fraction represents part of a whole. It's part of a whole. It's a piece of something. It's not the whole thing. It's a portion of it, a crumb of it, a fraction of it, might we say. A fraction is a part of a whole. We know that a fraction is made up of two pieces. We have the numerator, which tells us the number of parts we're dealing with when we talk about that whole. And we have the fraction bar, which tells us to divide. We learned this last week when we talked about division representation, that a fraction bar means to divide. And we have the denominator, which means or tells us the number of parts the whole is divided into. So for example, if we had a fraction of 3/5, our numerator is 3. Our fraction bar tells us that 3 is being divided by 5, which is our denominator. So 3/5, another way that we can read this is 3 out of 5. Because if we're looking at a fractional piece or a diagram, we would see 3 out of the 5 are shaded. That represents 3/5. So numerator tells us the number of parts. Our denominator tells us the number of parts the whole is divided into. And our fraction bar signals that this is a division problem. It tells us to divide. So I'm just going to draw some models here. Models that we've seen in the past that can represent fractions. So if I shaded 2 out of 3 of these, this would be 2/3 or 2 out of 3, like I said. I can take this next one and break it into fourths. And I might want to shade 3 out of 4, which would be 3/4. So this is how we would model our fractions, and we've done this in the past, We know how to do this. So we want to look at how could we take an improper fraction and make it into a mixed number, or how an improper fraction would be modeled or shown, and what is an improper fraction. So hopefully you remember that a fraction who has a numerator that is greater than or equal to the denominator. So it can be greater than or equal to. If it's equal to, it's still called an improper fraction. So we can have an improper fraction of 9/4. How would we model an improper fraction of 9/4? Well, first of all, the denominator tells us how the whole is broken up. So here I see a whole. So I'm going to break it into fourths. And here I see a whole. I'm going to break it into fourths. And here I see a whole. I'm going to break it into fourths. The numerator tells me how many of those fourths should be shaded. I should have 9 of them. So this would be 1, 2, 3, 4, 5, 6, 7, 8, and 9. So when we look at them, this is 9/4. I have 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4, 9/4. But not only do I see 9/4, I also recognize that I see a mixed number here. We know that 4/4 is the same as 1 whole. So this is 1. We also see that this 8/4 is another whole. So 9/4 is equivalent to 2 1/4. I see 2 wholes and I see 1 out of 4 shaded. So 9/4 is the same as 2 1/4. So that's how you can make or model a mixed number and see the slip scar. Yeah. Sorry, that is how you can model a improper fraction and see the mixed number portion of it. So let's try another one. What if I wanted to model too light? What if I wanted to model 5/3? Again, my denominator tells me how to break up my whole. So I see 2 whole boxes here, and I'm going to break them into sections of 3. How many of these do I need to shade? My numerator tells me how many I need to shade. So how many am I going to shade? 1/3, 2/3, 3/3, 4/3, 5/3. So this shows me the portion that is shaded. 1/3. I have 5/3 shaded. 5/3 means or is the same as what? How many holes are shaded? This whole thing is shaded. So that's 1. And then I have 2 out of 3 shaded in the next one. So 1 2/3 is the mixed number. Can everybody see that 1 whole is shaded and 2 out of 3 is shaded? Awesome. So that means 5/3 is the same as 1 2/3, where 9/4 is the same as 2 1/4. And we can also model this with mixed numbers and take them and break them into improper. So let's look at how that would go. So we have mixed numbers to improper. A mixed number is a whole number and a proper fraction. So we know that an improper fraction is a fraction whose numerator is greater than or equal to the denominator, where a proper fraction has a numerator that is less than the denominator. Okay? So we want to model 2 2/5. So if I was modeling 2 2/5, I would shade in 2 holes, 1, 2, and then in the last one, again, my denominator tells me how to break up that last one. So I'm going to break into fifths, 1, 2, 3, 4, 5. And of those, I need to shade in 2 out of the 5. So this is how I could represent, and you could shade the whole thing if you wanted to. This is how I would represent my 2 wholes and my 2/5. But what if I wanted to know, well, what's 2 2/5 as a improper fraction? So the question becomes, how many fifths are there? How many fifths are in 2 2/5? Well, the way to answer this question is we need to have everything represented in fifths. So this last portion is broken into fifths. These 2 wholes need to be broken into fifths. And where am I getting the fifths from? The denominator. It tells me how to break up my wholes. So I'm going to break this into fifths. So now all of them are broken into fifths. How many fifths are there? We have 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, 7/5, 8/5, 9/5, 10/5, 11/5, 12/5. So 2 2/5 is the same as 12 fifths. Okay, we know that one whole would have 5 fifths and the second whole would have 10, 11, 12. So 12 fifths is equivalent to 2 and 2 fifths. Let's try another one. What if we tried 2.5? 2.5. So 2.5 means I'm going to shade in 2 holes. And then I'm going to shade in half of 1. So I'm going to split it into 2 sections. And then I'm going to shade in half of a hole, or 1 out of 2. So I shaded in 2 holes and 1/2. Excuse me. What is the improper version of this? So the improper version, again, we will raise the question, how many halves? How many halves are in 2 and 1/2? So for me to know how many halves, I first need to have my picture broken into halves. So we broke this one into a half, but I'm going to show it. And I can take this and break it into 2 sections, because that's what that denominator tells me. So now I have each one broken into 2 pieces. So how many halves are there? 1/2, 2 halves, 3 halves, 4 halves, 5 halves. So 2 and 1/2 is the same as 5 halves. Do you have any questions on how to model improper fractions or mixed numbers? I hope that this made sense to you, and it makes a lot of sense to me. So I'm going to give you some time to try some. So we want you, or I want you, to try to model 10 thirds and 4 and 1/3. I'm trying not to make them too big, so you have to write all this stuff. 10 thirds and 4 and 1/3. How would you model this? Show me, take a second, pause your video, and show me how this model would look. 10 thirds and 4 and 1/3, and then write what is the mixed number here and what's the improper fraction here. How many thirds are there in 4 and 1/3? And in 10 thirds, how many wholes are there? Take a second, pause, and work it out. Welcome back. I hope that you did your practice, and let's see if you were right. So how would 10 thirds look? So 10 thirds, I'm going to bring my model down here. I'm going to draw circles for thirds because I just think circles work better for me. I know that's 3 thirds, 6 thirds, 9 thirds. This will give me my 10 thirds. So I'm going to shade in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is what 10 thirds could look like. You could have used a square and broken into thirds. Same concept. So what is 10 thirds as a mixed number? How many holes do you see? 1, 2, 3. So I see 3 whole pieces shaded, and I see 1 out of 3 shaded. So 10 thirds is the same as 3 and 1/3. I hope you got that right. What about 4 and 1/3? So 4 and 1/3 means that I'm going to have to draw 4 whole circles. And again, I'm just going to kind of sneak down here and do it. Probably more in the summary section. So 1, 2, 3, 4. And I know in the last one, I'm going to have 1 out of 3. So shade in 1, 2, 3, 4, and 1 out of 3. So our question now is, how many thirds are there in 4 1/3? How many thirds are there? So again, you could go in and draw your thirds, and you can write on your model and count it up. But I know this is 3/3, and this is 3/3, and this is 3/3, and this is 3/3, and that's going to be 1. So 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13 thirds. 13 thirds is in 4 1/3. There are going to be 13 thirds in 4 1/3. So this is part 1 of how to model improper to mixed. I'll see you for part 2 on how to do the algorithm. Good luck.